you can describe any data and the resolvers are just a function. Usually it's being just very easily set up on top of our existing APIs. But then once it's set up and we got a lot of the benefits and everyone is happy, then comes the next phase, like what do we do next? And for us, what we see a lot is that the GraphQL team usually is struggling to actually call the downstream services, because those are the same downstream services and the same issues are also there. Like those are services that are not typed. We still need to go there and we still need to figure out what the hell is going on there. And when they break, like we have, with GraphQL, we have like, we can prevent from breaking changes and all the cool stuff that we also know. But if the downstream services are breaking, they will break us anyway. So what we started in the process in the Guild is starting to looking at those downstream services the step after. Because usually when companies are calling us or like are contacting us is after they already implemented GraphQL and then they want to move to the next phase, and then it's the more, let's call it the next phase problem after you're already using GraphQL and you're happy. So some approaches of how to deal with like those backend services. Some of them are like, let's just rewrite them all into also GraphQL, make everything GraphQL and everything will be great. Let's be a GraphQL maximalist, everything GraphQL. And that's, might work in some companies. Another approach is maybe to build like small gateways or like small like servers or small proxies of GraphQL on top of the existing things. And those work. There's plus and minuses on all of them. Usually I talk a lot in this slide, but I think I'll skip and then we can also have a discussion at the end, just in terms of time. But as we went to approach this problem and we did it again and again and again, what we started thinking is like, what do we actually want from GraphQL? And some of the things is that we wanted a predictable schema to understand what is the actual data that we can query. And also we wanted a query language and an engine, so we can ask and send a query to that. And we're not working in a void, right? Like if we look at the existing backend services, they work and they're there. And usually, like when we look at most of our customers, like those services we can say that are, they're not the best, but they work. So what do we have there? Maybe we have an open API schema. So we have some kind of schema of the data that is there. Maybe it's a gRPC that also does validations, and we know that the schema actually equals to what's going on there. Maybe we have nothing. Maybe it's a REST API without anything, but we do have logs and we do have information about what's going on. So what we thought was, can we look at all those existing things that we have that are not giving us the right guarantee like GraphQL gives us, but it gives us something. And can we somehow shorten the way for us to get to where we want using those existing tools? So the idea was, can we look at all existing schemas that are not GraphQL or something else? Or maybe look at live data, understand from that live data what actually is happening, and then get those schemas, and then from those schemas just translate them into GraphQL representation. And that's GraphQL Mesh. So, and again, GraphQL Mesh, you can think about it as a concept again, not as the library itself, like there's many other implementations, but first of all, the first idea is query anything. Like we can take any source, kind of like what GraphQL is, right? GraphQL is just a function, and there's we can query any function. But in this case, we can take many different existing protocols like OpenAPI and Swagger, OData, gRPC, SOAP, or maybe JSON schema, which we can generate JSON schema from actual just traffic. Then can we take all of those, let's say in our case, OpenAPI schema, and with some configurations of letting Mesh know where it comes from, generate a GraphQL implementation, a GraphQL schema. Another example is like, this is just like an example network request. From there, we can generate JSON schema, and we can feed that into the Mesh config, and then that will also print us a GraphQL schema. Here is another example. like we have two GraphQL APIs, two GraphQL sources. One is for countries, one is for like cart, and another one is Stripe. But Stripe it doesn't have a GraphQL API. But now it does, because Stripe has an open API schema. So now we just edit it to mesh and we have three existing GraphQL sources. Like we can just have three schemas that we can just send queries to, even though they're not GraphQL at all. So that means that now clients or consumers can work with services that are not GraphQL as if they were. We can send a GraphQL query. I can talk even deeper about how we're technically doing it. Like we're not actually making a regular GraphQL execution. We actually make it more optimized. For each of these handlers, we have executors. So we make it in a more optimized way. But basically, I can send a GraphQL query to basically a service that has nothing to do with GraphQL, has no idea what GraphQL is. And the main idea was, let's take the best out of GraphQL using our existing services, and we can still use the original protocol that exists out there for many reasons. Like maybe converting this service to GraphQL was better theoretically, but everyone has work to do, and maybe even in many cases that we saw, the teams there, not only that they don't care about GraphQL, sometimes they don't exist. Right? Those are just services nobody wants to touch anymore. And then the next thing is, like, once we took all those different sources and we made them into a GraphQL representation, which is by itself a very interesting thing, because now we can store all those different schemas in one place, and now even just the conversation inside of the organization is all around a GraphQL schema. It doesn't matter if your source is a SQL database or an open API or a GraphQL service, we all talk in the same language. So, but once you do that, then we can do the next step, which is to merge them all into one single graph. Now, I'm not going to open the debate here into, do we want actually one single graph or multiple single graphs? Like, I have a lot of opinions about that. We can talk about it for 2 hours. But you can turn them all into one single graph or multiple graphs. So you can merge all those different sources together. So for the consumer, that means that for them, it feels like they're querying one single source, but at the end of the day, they're querying multiple sources. So it's a very, very powerful idea. And there's many different features. I'll skip some of them now, but once you have all those different sources, we also added all kinds of features like changing automatically naming conventions. For example, let's say you're querying a SOAP service, and in SOAP land, like everyone is doing everything capital case for whatever reason. Let's not fight about it. But the good thing is that we can now change it. So they can go and do their capital case, and then we can automatically change the naming convention for the consumer. So the consumer can we can automatically convert their into a camel case or whatever you want. We can also do some modifications in the configurations. So that means that I can not only query many different sources from many different technologies, I can also adjust them. And that means that I have a config that shows what I want, and then the provider they know what I actually need, which is another very powerful idea. So in GraphQL, the title of GraphQL Mesh is query anything that we just talked, but also run anywhere. And then the run anywhere, again, look at it as like a separate idea. The idea of run anywhere is that in the case of Mesh, we take all those different sources, we do those translations that I said, but this is a completely different step than the execution. What does that mean? It means that we take those configurations where all those different sources are existing, where are all those different schemas that we want. We can add custom resolvers, we can add all these transformations, and then we can build that. We do a build process that we can build or a gateway, that can run in the center of your organization and everything will run through it, or we can actually build it into an SDK. And that SDK can run anywhere. So that means it can run on your client. So we have many, many companies that for whatever reason, they're not ready to actually introduce a GraphQL gateway yet. So we take everything that I just showed you and compile it into an SDK. So over the network, or in terms of deployments and runtimes, nothing changed. It's just that the developer experience for the consumer, they feel like they're querying one single thing conceptually, but at runtime, they're still doing REST requests from the client to the server. And it's amazing how beneficial this thing is if we even put aside all the performance benefits of GraphQL.
Oh, wow.
So yeah, like I said here, like you can run mesh, or again, you can think about this theoretical solution as a central place, but you can also basically take all those things and compile it per even service. Like if you have a service like a machine learning service or that needs to query many different other services, the developers of that service will feel like they're querying one single place. But the people that are actually responsible on runtime and reliability and everything, they don't want to introduce a new central service, so we can just introduce it as an SDK. And then specifically in the GraphQL mesh part, we use JavaScript. But we built also an internal library, we also open sourced, and that's also something we brought to the REST world and the regular JavaScript world, is we built a library that basically abstracts away all the different JavaScript runtimes. So that means that not only that you can take that SDK, and that's true for any library that the Guild is building, not only that you can run it on the client or on the node server, you can run the same code on Bun, Dino, Cloudflare workers on Edge, any place. And you don't need to change any code. If we take that step further, we also have plugins into Mesh. So let's say one plugin is like response caching. Now, here is like an example configuration. So I'm taking a regular API, like a REST API. I'm generating JSON schema from it, and some example responses. Then I generate GraphQL API from it. And then I'm deploying it into Cloudflare workers, and I'm putting the cache into Cloudflare. So now that means that I took, just with this configuration, I took like an old REST API, and now I have a GraphQL API with caching running on Edge. And again, there's a lot of questions of caching, where do you want to do it, and where it's beneficial, but for many, many applications, running the caching and the storage, like using D1 or many other cases of storage on Edge, like you can get really significant performance improvements. I had a really interesting talk with a couple of people here that they need to serve their application in China. And then they had a lot of issues, performance issues there. And this thing was very beneficial for them. It also depends, of course, on the use case, because you still need to get to the original server, but yeah. Also conceptually, this is another library that we built. We have GraphQL, let's say we took all of that, we get the GraphQL service, or you can use your existing GraphQL server. What we've done is also the other way around conversion. Like many companies, they introduce GraphQL API, but they still want to, let's say, expose a REST API for, let's say, third-party partners, or maybe another team that is not on board the GraphQL hype train. So what we thought is like, can we, in our minds, GraphQL is kind of like a superset of REST. So can we maybe generate from our existing GraphQL APIs, can we generate REST endpoints? So we did, and that library is called Sofa. So now all this, the main point that I'm trying to make here is like, all these boundaries between GraphQL and let's compare GraphQL versus REST, GraphQL versus whatever, we don't think about it like that. We just think the fact that we can translate everything into GraphQL and the other way around, we suddenly started thinking about abilities, specific features that we want from GraphQL, and how can we start using them without coming to an organization and say, let's migrate everything to GraphQL, which usually is not the easiest thing to do. I'll try to keep it short and I'll just finish soon, but I just wanted to say that now that we think like that, we can take more abilities from GraphQL and tools even for GraphQL and bring that into the API world. So, like I said at the beginning, one of our main issues was that we worked with clients, they had GraphQL APIs, but their underlying teams kept breaking them. So the REST API teams kept making changes, and even though GraphQL protects you from breaking changes, the sources made breaking changes, and then nothing helps. So, when we knew that problem for GraphQL, we have GraphQL Inspector, which is a tool that statically runs on your schema and make sure that you're not making breaking changes. This is all kinds of cool features that it can do, but that's basically the premise of it. And then, so that's one thing. The other thing is, like, let's say, even if we do prevent breaking changes statically from different versions, sometimes we want to also prevent changes based on usage. So we need live data. And that's, in GraphQL, there's Apollo Studio, and also we introduced Hive, which is like both of them are schema registries, but also that are looking at your usage. So they can tell you, okay, you made a breaking change, but nobody used that field for the last 30 days. That's fine, you can make that breaking change. It's kind of like Google Analytics for your APIs. So all those things are very powerful features. I'm going to skip the example here, but you should definitely check out both Apollo Studio and GraphQL Hive. But all those cool features that those tools are giving you, now with the help of Mesh, that you can take all those things and convert it into GraphQL, you can bring those into OpenAPI. So what we've done as a first step, we went into the teams that we were querying, the REST API teams, and we just placed Mesh and Hive into their CI/CD. So now we failed their CI/CD when they were about to break us as the GraphQL consumers. And that's, I think, the main point here. Like, we used GraphQL tools in an environment that is not GraphQL to get some of the benefits of it. And those were very, very beneficial. So the my main point for today was maybe don't think GraphQL, just think APIs. And try, if you're in a larger organization and you can't rewrite everything from scratch, try to leverage what you have already. I know every developer hates the code that they inherit, but in this case, maybe try to work with it. And gradually evolve into that perfect situation where, if you think that everything GraphQL is the perfect situation, gradually evolve there. And use all kinds of tools to take the stuff from GraphQL into the other API world. That's it for me. There's many different, who is after me in terms of schedule? You? Okay. So I'm really excited for your talk. I'll just say that in the Guild, everything that we build, every library is under a person. And the main person that worked on GraphQL Mesh and did all that work is Arda. So I wanted to mention him, and you can follow him on GitHub and Twitter. And I'll just mention again, first of all, the event next week. If you want to join in Berlin, if any one of you want to get a free conference day. And most importantly, GraphQL Conf. I highly, highly recommend you to join. I think it's going to be really exciting there. So thanks.
Hello everybody, my name is Toorn. I'm 32 years old, from the Netherlands, so it's a home name for me. I'm now working 2.5 years at capi and working there for Albert Heijn. Really exciting to see so many people here. I think we sent out the invites like 1.5 weeks back. I think you first came in contact with us the 4th of June, so that's really a short time to organize this. Today I want to talk something about Albert Heijn, the challenges we face, the solutions we have, the monitoring, and some roadmap we have planned. And we really want to start a conversation after this. So yeah, please reach out to us after this one. Albert Heijn, I think most of you know, but it's the biggest market concern in the Netherlands and also operating in Belgium. They have a total of 1,100 stores in the whole Netherlands. And in addition to the physical stores, they also they deliver groceries, and it became the second largest web shop of the Netherlands after bol.com. There are currently working 500 people on the IT department with for web shop app and cash registers. So everything used to at the cash registers for self-scanning stuff is also maintained there. We are working now with 30 front-end developers on all these parts of the organization. And those are divided in multiple teams, like products, basket, and profile team. I think for every team there's someone here. And each team is responsible for a specific feature or functionality in front end. Myself and Tom, also somewhere here, I'm not seeing him, and Arjen, the main people you can ask questions to after this talk. We are working for the API platform team. We are responsible for the landscape of GraphQL in our organization. So we create a paved road so every team can use GraphQL. And in addition to the gateway, we manage other stuff, but that's not for this talk now. So first, why did we start using GraphQL? Maybe it's a good starting point. We saw that a lot of teams are creating their own BFFs to consume data from the backend services, and they have all their own interpretation of data, and many times that went wrong. So we want to create a single source of truth where every team could find data that they need for their application and use it the same way for every team. So the end goal is remove all the BFFs from the teams and have GraphQL as a main source for our organization. We choose for a mono repository to speed up things, like a lot of teams working on the same stuff, but we have, as API platform team, have the role to have everybody on board, to do the same thing, to use a good schema, and not everybody is aware of how to use GraphQL, so we can monitor that really good. That also has, of course, some challenges, and therefore we also start with GraphQL modules. As one of the early adopters, I asked around within capi. I think one of my colleagues there started a conversation with you in 2018 or 19 when GraphQL modules were first coming there. And then that was really, for Albert Heijn, a really good point. So as example, modules you can, I'm not sure how many people do use GraphQL modules? It's not a lot. It's not. But GraphQL modules, you can easily split up your GraphQL schema, and it's also from the Guild. And you can easily encapsulate GraphQL types, resolvers, and also schema and other related functionalities, so like normalizers, serializers, and stuff like that. And in that way, we could, within one repository, we could split up every module that every team is responsible for. So for the profile team, they have like an account module, and for the basket team, they have a basket module, but also maybe a second module for that. So that's what I tried to show there. Next to that, we split up the repository in different packages. So we have multiple reusable parts. And so the GraphQL server, I'll explain that later why we did that split up. The REST client generator, auto-generated clients from servicing using OpenAI definitions. So it's also something to keep in mind. An end-to-end test runner, GraphQL client that's used by all the different teams. So every team that has their own web application can use that GraphQL client to fetch data. And if you want to change something in the GraphQL client, we have one place to edit that. So within such a large organization, we also had some challenges, of course. So with 8 teams working on GraphQL at the moment simultaneously, you can imagine that you need everyone on board. This is what I already mentioned before. And we managed now for almost every team to have their team, that they are responsible for their modules within our module repository. So we have in GitHub, we have a code owner file that specifies what team monorepo. So when something changes in their module, they have to approve that something has changed in their module. But we can also do changes in other modules. So we have, we can work together quite nicely. And all the package around that's maintained by the API platform team. So next to that, we also created alerting for the resolvers. So every time an operation is called, we also send to the logs what team was responsible for that module. So in our logs we can see who is responsible for what and alert them about some resolvers not functioning. And at that point, of course the services behind should have logging, but we also see that not always happen quite as good as we do. And since all the data comes through GraphQL, we felt responsible to also notice that. So we see that sometimes now it's easier through our GraphQL gateway to see where the problem is. So here's a little example of a Teams message the teams will get. So they see directly what's going wrong with a link to the Kibana logs and what's happening there, so they can easily pinpoint their problem. So the next thing was a question from our organization that Ahold is, Albert Heijn is a part of Ahold, and Ahold is a bigger organization that also have Ethos and Gal that are 2 different companies. Ethos is more like, how do you call it? Pharmacy, yeah. And Gal is more for the drinks. And there are some data between those companies that is the same. And in this example, we have a savings program, Air Miles. I'm not sure if everybody is aware of that. You can, for every time you do groceries or stuff like that, when you have Air Miles activated on your bonus card, you get points, and eventually you can also pay by your Air Miles. But that miles balance, how many points you have, that is for every store the same. So on Ethos you would see the same amount of points as the same amount of points on Gal or on Albert Heijn. So they asked, couldn't we use the data from the Albert Heijn graph for our Ethos or Gal? And we're like, yeah, we can do that, but should we expose that? Should we expose the whole graph for Ethos if they only want to use the miles balance? No, we didn't want that. And isn't it strange that ethos.nl links the user GraphQL query to albertheijn.nl? That was something we could easily fix with some DNS tweaks or something like that, but we took a step further than that. So how did we solve that? So this is the old situation where we have modules on the top, the GraphQL server, and aha.nl. I don't need to forget the app, because app is also consuming the GraphQL server. And the easiest way, as what I mentioned, was like this. So facilitating the data to ethos.nl and gal.nl. And what I mentioned, we could easily fix that with the DNS entry, but that was not the ideal situation. But then the modules came in very handy. So with the modules, we had now a split up between Albert Heijn modules and common modules, and we created a separate server for Ethos and Gal, and we had already the servers for Albert Heijn. So in this case, Albert Heijn modules and common modules, we both send them into the AHA GraphQL server, so they use the same data. But that same AHA Miles module, we send it to the common server, and that's used by Ethos and Gal. But if something's changed in the module, it will be for all 3 patterns. And that came also to a future problem probably, because when we use GraphQL, when we started that, we are really excited. So probably Ethos and Gal will also be excited. And what happens then? This will probably mean that we need to split up the repository. Since Ethos and Gal are not directly in the same IT department, we cannot facilitate everything for them. We are still a bit struggling with that. What if this happens? What's going to happen? So please feel free to talk to us if you have any ideas, because we're really open to start this conversation. So as what I mentioned before, most teams have monitoring in place, and services that are consumed by GraphQL should be monitored. But as I mentioned, that's not always happening. So in the last half year, we moved from Apollo Studio to Hive, as what Uri already mentioned. That's the time we had a lot of conversations. Hive, I would really like everybody to look into that. I'm not sure, are there people here using Hive?
No.
Not that many, again. Since we work in such a large organization, you're always busy with budgets and stuff like that. So doing that step from the one to the other is sometimes not that easy. But Hive had also a self-hosted way to have Hive in our organization. And since we have a lot of people with knowledge of hosting stuff, it was really easy to set up. And the main thing was pricing. Apollo Studio went like doubling their price to use Apollo Studio, and we were like, aren't there any alternatives, since we have so many logging already in Prometheus, Grafana and stuff like that? What do we really need from such a tool? So we did some investigation, and Hive was then the first thing that came up. So next to Hive, we use Prometheus and have some Grafana dashboards to show each team for their module what the errors are. And they can easily see their errors in the Grafana dashboard. That's also linked in the Teams message I showed you. So I think Yuri just skipped a lot of Hive. I like that, because now I can dive a bit into Hive. So this is the Hive operations dashboard, where you can see how many operations are done and stuff like that. But since we are using the self-hosted Hive variant, we did some additions that we were missing from Hive. We know that they are working on it, but since we think let's build something on top of that. As you see on the top, we have created a usage reports button, and the biggest thing we missed now was insights in our deprecations about a specific field, by what client it is used and what version. Because we are also working with app, and app has versions, and we cannot remove stuff, and we want to chase stuff to get deprecated. So app is now using a lot of different versions, but sometimes you can ask them to hard kill something. It's not always easy, but sometimes it has to be done. So when you click that button, you will see this overview. And I selected now the basket products query, and when you select the query, you see for every client a different graph and how many times it gets called. I'll dive a bit in the details. So on top you can select the target, production, or what query you want, or what field, or what type, and it's auto-filled. And here you see on the top, you see the client. So in this case, it was AHA checkout. The field basket products, how many times it got called, on what day. So it goes 30 days back, and those 30 days are in common with our breaking changes rules to remove them. They should be all gone. And this is how it looks like when something is deprecated. So this one will be safely to remove in 19 days, I think, yeah. So in this case, we can check if someone is using it and chase the teams to let them really remove some fields. So if we keep growing, there are some things on the roadmap. Should we split up the repo? And yeah, think about that. That shouldn't be that pain of the ass, since we use modules and packages and stuff like that. It's more like cutting things in pieces and having everything work together again. Should we move to a federated setup, mesh, anything like that? And how do we make our GraphQL gateway more robust? Since there are a lot of calls, and we want to look into that, how that will manage. So if you have any input, yes please. And please reach out to me, or Tom, or Arjen. I think Arjen is there. And Tom. Tom is there behind the tree, hiding, waiting for the questions. And I want to thank you all, and have a lot of fun this evening.
So I'm Shokhrukh Umriyaev from Guild.com, and here I'm going to talk about how to use GraphQL in backend for service-to-service communication. But before that, let's talk a bit about Booking.com. So it started in 1996 as a small startup, and nowadays it's one of the largest online travel platforms, offering a wide range of products, starting from accommodations, transport, flights, attractions, and many. Our mission is to make it easier for everyone to experience the world. And we are a global travel industry. We provide to our travelers a wide range of travel products, and at the same time, we cannot do that without our partners, to whom we are partner to millions of entrepreneurs of all sizes that use our platform to promote and sell their services. Our vision for the future of travel is to leverage technology to make it easier to experience the world. And our search results page, which I think a lot of people here are familiar if you use Booking.com or ever used it. It's a stark example of how we are making that vision a reality. So in order to render this page to millions of our users with the lowest latency possible, with highest availability possible, we need to query a lot of content stored in hundreds of databases. We cannot query all of them in real time because from the tech interviews or system design interviews, we know that it would be very costly, or we would need we would have very low availability. So what's the answer from system design questions? Caching. So we pre-materialize data in background, and then for our search results page, it's mostly like key value lookup for each of the accommodations, which need to be displayed on the search results page. Previously, it used to be a monolithic service with materialization component, which would query all these data sources, which it doesn't own, apply some business logic on top, and put it on a monolithic schema, and publish if there are any updates detected to our update stream on Kafka. And for our search results, we have a bare metal backend, which had two important threads, request handler thread and update consumer thread. And this bare metal box was being shared between two very important threads, and the update consumer was consuming the updates from update stream and putting it in a RocksDB storage, and then the request handler was using that RocksDB storage, which is in-memory database, to serve the data to our customers in lowest latency possible. But the problem is, there are several problems. First of all, this is a bare metal setup where this disk and memory I/O are shared between two very high frequency threads. So because we have thousands of fields in our materialized data schema, when any of those fields change, regardless of if this search results backend is interested in those fields or not, they still receive updates through the update stream, which creates enormous load on the disk, because RocksDB is both disk and memory intensive. And then it caused us availability issues multiple times in the past. So, like I said, we have hundreds of databases being queried by a monolithic service with a monolithic schema being pushed to the update stream, which is used by many different consumers through both the Kafka topic and through the API. So, we don't have any separation of concerns here, or we don't. So, both business logic and data retrieval logic were mixed in the same code base in the materialization service. We didn't respect ownership boundaries. So all of these data sources are owned by different teams across the company. And this service was querying all of those directly from the data source. And then it was a monolithic schema and monolithic service, which was shared between many different consumers. So what could we do? Back in 2019, Booking.com, together with Apollo Studio, started working on leveraging GraphQL to modernize our front-end architecture. So we were moving towards micro frontends to use GraphQL for interoperability between front-end and back-end. It's not news to anyone, right, to use GraphQL for that. But then we thought, like, could we use GraphQL for backend service-to-service communication? Because our use case matches the use case of GraphQL. Like, we are connecting different schemas, different models together into a big super schema. But the only problem for using GraphQL in backend service-to-service communication is it causes very high latency compared to, for example, protobuf. Right? So serialization is way slower compared to protobuf. But for us, because as I mentioned, batch materialization or materialization process is an hourly process. It happens in the background. Latency wasn't an issue. For us, the trade-off between latency and what we would get from the GraphQL, which is observability for which fields are being used where by whom, and also a single, like, centralized, standardized API, which is Graph API. It was a better trade-off for us compared to latency, because we didn't care much about the latency, because it's a background job. None of the real-time requests would cause any request to this backend. So, like I said, the materialization happens hourly, so for us it was fine. So we decided to use GraphQL for this use case. In the high level, it looks like this. From from schema perspective, we have many data services who define their schemas. Then they publish it to the Federation gateway. It stitches those schemas together into one supergraph, published to our clients. Then our clients send GraphQL queries to the Federation gateway, which in turn orchestrates data fetching for each requested part of the query. If we go into detail, so now we have subgraph services in front of each of the data domains. Like, we have a hotel data subgraph, we have review score subgraph, room subgraph, photo subgraph, which are then stitched together into a supergraph on a materialization federation gateway layer, which then is queried by search results materialization service. And it stores the results after applying some business logic to the Cassandra storage, and then materialized data API service works as an API on top of this data, and search results backend is now stateless because this data was moved outside, so that we could also move this bare metal component into containerized Kubernetes environment. Moreover, we are now respecting the ownership boundaries. So hotel data subgraph service lives and owned by the same team which owns the hotel data. Same goes for review subgraph. And for the search results team, they own the entire ecosystem of serving the data to the customers through the search results page, and also preparing that content for them to serve it in lowest latency possible. And then the Materialization Federation gateway is in between, connecting all those parties together and doing an awesome job. So in example, like I said, so there is a rooms data source, there is photos data source, facilities, etc. All of those data domains, they can define their own GraphQL schemas, as Uri also mentioned. And on the federation layer, we merge them into one super schema. And then this way, we can allow the accommodation details page content materializer to request only the fields they need, which is photos and rooms, for example. And search results page content materializer to request for main photos and facilities, which is what they need to display the search result cards, for example. So we allow those many different use cases, and they are only querying the fields they need. They are only materializing and caching the fields they need. And at the same time, they are not breaking the ownership boundaries. They are talking to the materialization or GraphQL layer, through a centralized GraphQL service, which in turn is taking care of providing a centralized API. So now we are respecting the ownership boundaries, because now we have microservice environment where ownership boundaries of all the components are respected. We get observability out of the box because Apollo Studio provides us field level usage observability, not only on the field but also on the subgraph level. And previously our materialization component was tightly coupled to only accommodation data. But now this platform can be used for all the travel products we have, including flights, car rentals, attractions, taxis, and also different types of accommodations. Thank you very much. This was me. I'm not sure if we have time for questions. So, if there are any questions? Yes?
So how long did it take to convert to this platform, and how many people were involved?
So this took about half a year for 2 teams, because this was a new, and we had to rewrite many data fetching logic into GraphQL. But after the first big use case, onboarding the second use case took less than a month, for example, because we already had many data sources available, and then they could reuse a lot of things already.
So 2 teams of what?
Two teams, like 2 platform teams. This is a backend system, so search results backend team and materialization ecosystem team. Yes.
Booking is well known for its data-driven experimentation platform. How do you handle experimentation with serialized data?
So, very good question. So, in order to migrate the search results page from the old materialized view into a new materialized view, we ran A/B testing on the page level. So we had 2 sources of materialized data, and then on the page we were doing coin flip, and based on the result we were showing either the old view or the new view. In the new setup, after this showed us that our latency increased only 20 milliseconds, which is very good considering that we are replacing in-memory access with network access. But at the same time, so this search results backend, it has very good experimentation tracking capability. And what they do usually is they create experiment fields and not base fields in the GraphQL schema. And based on the experiment results. Either they fully migrate to the new field and clean up the old field, and vice versa. The good thing about GraphQL and like from observability perspective as well, like as I mentioned, previously with Protopuf, we also were doing that, but we didn't have, as a platform team, we didn't have any way to monitor if the experimental fields are still used or not. But with GraphQL, now we have this capability. Any more questions?
Yeah.
Yes.
Yeah, is the API for companies outside of Kuwait, is it also converted to GraphQL?
Not at the moment. We don't. Maybe no. Well, we don't have any. No, not at this moment. But if you have any recommendations or questions, maybe you can reach out to the contact information. Any more questions?
Do you have any learnings from this experiment? Was it a good experiment? Was there any challenges?
I mean, because it involved interaction between two teams residing in two different departments, of course, in the beginning it was a bit challenging, like to scope out the problem, like to get buy-ins, but because we all were working towards the same goal, like the search results backend, they wanted to containerize their bare metal service, and we wanted to like replace the monolithic architecture with more like microservice architecture based on GraphQL. We were able to find a common ground, and we worked together after that. So it was easy. Yes?
Why you choose Federation stitching versus the Guild stitching?
Because in versus Guild stitching?
Yes, they can provide another way of stitching.
Okay, so in our case, like I mentioned, back in 2019, we already started using Apollo Studio, and we decided to like reuse most of the things. Yes. I think I am out of time, right? Yeah. Thank you very much.
And now we have Marion from Hasura with a bit of a spicy talk. GraphQL without relay is not worth it. And after the talk, I think we'll do like a Q&A session with everyone, all the speakers, while we sit on the couch or something and you can crucify us and stuff.
Okay. Hello everyone. First of all, I just want to say a big thank you to Uri, because he's kind of getting very active to getting all the GraphQL meetups in Europe back, and I'm just tagging along with him. And so just big applause to Uri, please. So yes, my talk will just be like 10 minutes, so very soon we'll be able to go back to drinks and food. I made after the Q&A, I made the title a little bit less kind of, controversial, so it's moved to kind of scaling UI development with relay GraphQL. So, but yeah, it actually, I'm basically saying the same thing. Quick introduction, I'm working for Hasura. Who has heard of Hasura before? That will help me kind of adjust the talk a little bit. Okay, so just very quickly, so Hasura is a tool to auto-generate production-grade APIs on all of your data. Originally we started with Postgres, now we are supporting any kind of database including MongoDB and others. And what I'm most excited about, which is something that is happening in my team, is we're adding the capability of building APIs using AI. So the first step towards this will be supporting vector DBs, and then we'll be moving to supporting a lot of AI agents. This will be probably my next talk when I come back to Amsterdam, hopefully. Then very quickly about me, I'm from Switzerland, and in my free time I like dirt biking for adrenaline and ballet for expression of arts. So if you want to talk about dirt bikes, like, catch me after my talk. Cool, very quickly about the agenda. First I want to talk about our challenge that we face at Hasura, which kind of made us want to use Relay. Then kind of the two options that we saw that didn't work for us, and then the solution that we found. And in the end, kind of now how we're working towards this solution. So, if you have heard about Hasura, you know that we support different way of building APIs. We have an API to build the API, we have an CLI, and we have the Hasura console. Now the Hasura console is built on React. So now that the product is getting bigger and we want to ship more features, we want to scale the UI team. Now we added more people to the team, but it didn't scale because we had a lot of problems to parallelize the development because of UI ownership. We were not able to kind of say, okay, this team owns this specific component and so on. So we saw two options. One of them was to have independent micro apps. Now this will not work. I mean, we looked at it, it won't work because each section of the UI would take too long to load because from every microservice we would need to load assets. And in the worst case, it would not load at the same time and then it looks terrible. It's a terrible user experience. Even worse, if you would switch to another tab, there would be a reload, which is like, this is the no-go these days. Yes, so if you make each component make your own API, then there's also a lot of redundant data fetching, which affects performance for the worst. So data is also not synchronized across components, and this can lead to inconsistent states. So we might actually show wrong data in one of the components, and even worse, different data at the same time. And also, the worst of all, everything would go through the root component, which then it makes it impossible for the components to be owned by separate teams. So this option one didn't work for us. Then we looked at another option, like let's keep the UI components that we currently have and just assign owners to each component. Now this is very hard because there's always shared state still between these components. And the global state store gets used and modified by all of these components, and then these can call regression. So if we change something in the root component, then we are not aware of other component that is owned by another team, then we might break it without realizing it. Yeah, and the data fetching responsibility is always at the root node, which cannot be owned by a single team because everybody is working on it. So this also didn't work for us. So then we were looking at a relay style GraphQL. So in this case, each component should have an owner, and this owner should be able to work on their component and define the data that belongs to this component independently of everybody else, of every other team, of every other component. The relay compiler, which is demonstrated here, looks at the component tree, this is how relay works, and merges everything into a single query. This makes sure that the state gets updated reliably in all the other components because everything is managed by this single query. Also, there's no redundant data fetching because everything goes back to this compiler. Relay maps, this is the big advantage that we get from relay maps, GraphQL fragments to React components. And as far as we're aware of, there's no other API fetching technology that solves this problem so far. If you know of any, please let me know because we're still kind of in the beginning phase of building this out. Okay, so now we have some challenges because Hasura is now pretty advanced. We have a lot of different data sources. So we don't only have the GraphQL API, we also have actions for business logic, we have remote schemas and event triggers and so on. So the current version of Hasura doesn't cover all of these features yet on the relay. we're working on V3 that will come out in a few weeks, and then we will support all of them. But this is one of the challenges because it needs to extend the spec of Relay to support all of these data sources. Yeah, and another thing is that connection paginations and some of the other functionalities that Relay offers are a little bit complex, so it takes some time to add support for all of this. Now, how are we approaching this? So again, this is very early state of the project, and I would love to get feedback on if you think this makes sense, if you already have a solution for this problem. But what we are planning to do is, we anyway do a lot of dogfooding in Hasura. I mean, Hasura Cloud is built on Hasura, so we use our own product basically to build the product. What we're doing now is to do the same to build APIs. So a Hasura Relay API for the console is something that we're working on, but with a simplified spec. So it won't be just Relay, it will be Hasura Relay, because the Relay spec is quite complex to implement, and we want to make it very easy for developers so that you can very easily have component ownership separated in your team, and therefore scale your UI team as well. Some server support is already present, of course for tables, at the server level of Hasura. But for example, Hasura doesn't provide global ID to all of the data sources. One of the examples is that, for example, views don't have primary keys. So at the moment, we don't have support for Relay for this reason. But with the V3 version that will come out in a few weeks, we will have full Relay spec compatibility, plus more for all the other things that we offer at Hasura. Yes, and our vision is to make any API and any data source into a Relay compatible API for this reason, so that we can scale UI teams. Now the question that we're asking ourselves is, first of all, do other people have the same problem? Like, how do you work on who is a front-end developer? Has anybody solved the solution of a component ownership without extensive collaboration within teams? I mean, if yes, please approach me afterwards, because I would love to know how you do it. Because this is more or less, okay. Yeah, let's definitely talk afterwards, because yeah, for us this is currently the way that we want to solve it, but we are also thinking, because this project is very early stage, we're thinking maybe we've missed something, like maybe there's another technology that we don't know of that already solves this. And otherwise, I would also be interested, like, I don't think a lot of, who is using Relay? A little bit. Yeah, not so many people. So Relay, kind of, for what we want to use it, it seems very powerful, but we also know not many teams are using it. So would love to know why. I'm assuming it's because of the difficulty of the spec to implement it with the GraphQL API. But please give me any thoughts that you have. And also, of course, if you think it's useful, because this will be something that we will open source to the whole community, that you can make your API also Relay compatible. Yes, with this, I will soon hand over to Uri. I have stickers and pins for Hasura if you want. I'm around. I would love to hear about your solutions to UI components ownership. And thank you so much for listening.